Question 4 is coming from organic chemistry. Compound S is used in flood flavorings. A possible synthesis of S is shown in this figure here. So we have an alkene here, butene, then HBr here, then we form Q, then there is potassium cyanide in ethanol. Of course, that is a substitution reaction. This one actually is the one that extends or that grows the carbon chain. We are seeing this one added on, and then this is an acid added here. So it is an hydrolysis reaction. Then this one goes to a carboxylic acid. Okay, and then they are saying here that part A, P, Q, R, and S show stereoisomerism. P, in stereoisomerism, we have geometrical isomerism, and then we also have optical. So in optical, there has to be a chiral center. That chiral center must be connected. It is that carbon atom which is connected to 4 different groups of atoms. And then geometrical, we can have cis or trans. Okay? And here, for optical, we are going to have those isomers which are non-superimposable. Just like you can look at your fingers, okay? When you bring them together like this, they fit on each other. But if you get one, your palm, and then you put it on top of the other one, okay? You put it on the skin of the other one on top, so they are non-superimposable. That is how it is. All right, now let's go to part A here. They are saying that we complete the table by putting a tick, the type of stereoisomerism that each molecule shows. The type of stereoisomerism shown by Q is given. It is optical. Now let us, by the way, first find out what is done here. When I put HBr, then we are going to have CH3. Remember, this one here is CH3, CH, double bond, CH, CH3. Now, this one, let me actually write it like this. We can have the CH3 is down here, CH3, then there is a hydrogen here, then a double bond, then there is a CH3 here, and then this one here. So this one is going to be trans. Are we there? Trans. Because this one is different. I mean, is on this side and this other one is this way. So there has to be 2 groups on each of the carbons in that double bond. Okay? The 2 groups have to be different. And also here, these ones can be different, but then when you have 2, like but1 in, this way there is H and then H here. So that one doesn't have the isomerism. So you have this one, and you are also going to have let's say the hydrogen here, double bond, and then a hydrogen here, then a CH3, and then a CH3 here. Now this one will be cis. So P has geometrical because it has cis and trans. So I'll put a tick here. Now let's go to Q. When I put HBr, we shall have, you can put a hydrogen here or here. This one is symmetrical. So we can have CH3CH2, then CH, and then CH3. So here we shall have the bromine. Maybe the hydrogen went onto this, and then the bromine came onto this one here. Now, this carbon here is connected to this group here, is different from this one, is different from this one, is different from the hydrogen here. In fact, I can take away the hydrogen here, and then I put it up here just to make sure that you see the groups attached to that carbon. So this one is a chiral center. Okay, so that's why they are saying it has optical isomerism here. You see that? Because there is a chiral center. And then let's go to R. R here, there is a carbon. There is a silent hydrogen which is connected with that carbon. Remember, this is skeletal. So this is CH3. So this group is different from this, is different from this, and it is also different from this one here. Okay, so this one also has a chiral center. So that carbon there is a chiral center. So because of that chiral center, even this one will have optical isomerism. How about S? Even this one is a chiral center. This group is far different from this one here, and there is a hydrogen silent there. So it is the same thing. We shall also put a tick there. And then B Roman 1, give the structure formula of Q. We have already written it here. CH3, CH2, CHBr, CH3. So I will just write that. CH3, CH2, CHBr, CH3. If you want, you can put this one down here, that this is the Br down there, no problem. But if they said molecular formula, for molecular formula, you are giving the number of atoms that are present. Carbons are how many? 1, 2, 3, 4. So then you put the 4. Hydrogens are how many? Okay, are they 9? Then bromine. That is what we call the molecular formula. It is not the structure formula. So for the structure formula, we are seeing how many hydrogens or which atoms are actually connected to which atom. So this carbon here has 3 of them. This one has 2, then 1, and then the Br. Then, like that. So that is that. Then name the mechanism in reaction 2. In reaction 2, we are seeing this bromine here being substituted by this. And the reaction is substitution, but the mechanism is nucleophilic, because we get this one here, this cyanide comes to this carbon here. This one has a partial negative charge. This carbon here has a partial positive charge because this one is electronegative, okay? And then this one comes off. So this one, which is negatively charged, it is negatively charged and it is rich in electrons, okay? So because it is rich in electrons, what is the meaning of nucleophile? Phile means love. Then nucleo, it loves what is in the nucleus. And in the nucleus of an atom, we know that we have protons and neutrons. Neutrons do not have any charge, but protons are positively charged. That means whatever loves what is in the nucleus must either be rich in electrons, such that it shares with these protons that are positively charged, or it has to be negatively charged. You see that? So the mechanism is going to be nucleophilic. So the mechanism here is going to be nucleophilic. Nucleophilic substitution. It can be SN1. I think you know something like SN1 or SN2. Okay? Yeah, those are the ones. That's nucleophilic substitution. And then Roman 3, complete the equation for reaction 3. R is represented by, as C4H9CN. Now for reaction 3, remember, there is hydrolysis, okay? This is hydrolysis. So it's acidified water that you add there. So we can put hydrogen ions and then also water, acidified water. Then we get the carboxylic acid, C4H9, then COOH. Now, something comes off here, an inorganic compound. If the acid is HCl, when this one is hydrolyzed, we are going to form ammonium chloride, okay? But since I'm just putting hydrogen ions here to represent the acid, then I'm going to pull off this and then it will be ammonium ion. So that one will be ammonium ion here. Now let us balance. Of course, these are 2 oxygens that have been added, so I'll put a 2 here. You see that? And also, by the way, this one has to be plus to balance even the charge. You see that? Now let us look at what is here. The hydrogens here are still, but there is 1 here, then plus the 4. Those are 5. Then these are 4 plus 1, 5. So that is the balanced equation. Part C, compounds S and T react to form organic compound U, which has a single functional group. So we are seeing this one here. And they have given us in this table the data from the mass spectrum, M plus and M plus 1. So when they give you the M plus and the M plus 1, their abundances, these ones help us to actually find the total number of carbon atoms present in that compound. Okay, so they are saying use the data from that table to show that U contains 7 carbon atoms. So we shall say number of carbons is going to be equal to, the formula is 100 out of 1.1, then times the M plus 1, the relative abundance of the M plus 1 peak, then divide by the relative abundance of the M plus. Now, this is 100 out of 1.1, then times the relative abundance of the M plus 1 is 0.55, and then for the M plus is 7.2. When we put this one in the calculator, what do we get? 100 out of 1.1 times 0.55 out of 7.2. That one gives us 6.944 recurring. 6.9444 recurring, which is approximately what? 7. As simple as that. Then next, they are saying figure 4.2 here shows the infrared spectrum of U. And then the next part, they give us the functional groups containing the bond and then the characteristic infrared absorption ranges. They are here. Then they are saying use figure 4.2 and 4.3 to identify the functional group in U. Explain your answer fully. Now, let's go back to U. U has 7 carbon atoms. How many carbon atoms do we see here? 1, 2, 3, 4, 5. You see? Then you react with something here. This is a carboxylic acid. Then here, what you get, then water is given off. Don't you think this is an ester here? This looks like an ester because, and of course this one has to be an alcohol. Because when you react an ester, a carboxylic acid with an alcohol, you get an ester and then water. It's a condensation reaction. So therefore, and of course, since these ones are 5, then this one should be having 2. In other words, that is ethanol. Okay? So, but when we go to, if it's an ester, if U is an ester, let's look at the infrared absorption for an ester. We see an ester here. This is 1710. Okay? 1710 to 1750. Now, do we have that one there in this spectrum here? 17, this is the one here. 1710 to 1750. So we have seen that one there. So I will just come to this one here and I will say that the functional group present there is an ester. Okay. Then I will say explanation, there is an absorption. There is an absorption at we are seeing 1710 to 1750, okay, per centimeter, which indicates what? The presence the presence of now this bond here, C2O, C double bond to O, okay? But also, if you check here, there is another one here. There is a peak here, 1000, this is 100, so this is 1000, or it is in between here, 1100, this is 1200. Now, when we check in our group for an ester, remember an ester has something like this, and then that. So there has to be that bond there. Let's go and we check it out. Okay, C2O, it is in hydroxy because you can have an OH. Okay, yeah, you can have an OH for an alcohol, but for an alcohol we have something big. Okay, the peak is wide, and what we are having here is not a wide peak. For an alcohol it has to be big like that. So we shall come to this one here, and we say that you have already seen that 1040 to 13, that one we have it. Check, it is here, 1040, maybe around there, to 13. 13 is around here. So we are seeing that peak within that region. You see that? So I can also add on and say that there is, this is 1 point, maybe another one, absorption at 1040 to what? To 1300, which indicates the presence of C to O bond, like that. And then Roman 3, T has a single functional group. Remember T, for us to get an ester from a carboxylic acid, the carboxylic acid must react with an alcohol. So they are saying T has a single functional group. Use the information in C Roman 1 and your answer to C Roman 2 to identify T and U. Okay? First of all, T, where is our T here? Yeah, T is here, then and U here. So since this is 1, 2, 3, 4, 5, then I'll just put, this one has gotten 7 carbon atoms. So we shall get OH, then this one has to be CH3, CH2. No, CH2, CH3. Such that this one loses the H, then the OH here, and then we shall get these 2 carbons plus the 5 here to get the 7. You see that? Okay. Now, we are going to go back here and we say that T has to be ethanol. So I can write ethanol, CH3, CH2OH. Or since they have given skeletal, then I will say this one is that. Then another carbon, this is a carbon, this is a carbon, then the OH. So these carbons that are connected to the hydrogens directly, those ones you don't show them in the skeletal. Neither should you show the carbons. So I can just put this, then I show the OH. And then the ester, remember, I said it is going to be CH3, CH2. It has 5 carbon atoms. When you go back and check here, 1, 2, 3, then there is this one down. Then there is this. So those are 4. I'll come back here and say CH3, CH2, then CH. Now there was a COOH here. Okay? Then there is CH3 here. So if I put OH here, then CH2, CH3, I'll take away this one here. So meaning I'm going to have, I can even switch this. I put it here and then I take this one here. So I can have something like this. Let me change it a little. We can have it like this, then put the COO here, then the CH3, then I'll put the CH2, CH3. Or I can write it as this, that, this is 1, 2, then there is this one, then there is this CH3 down here. So I can then put this one here down, then here I come to this carbon. This carbon has, this one is a carbonyl here, then this one is connected to the oxygen here, and then that oxygen is now connected to the ethyl group. Okay, by the way, is my oxygen. My oxygen is here, then the ethyl group. So you can put this one or this one here, this one or this one here. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.